Good afternoon everyone, I am Evelyn Joyce Lavado and today I will going to discuss to you our new topic in number theory, which is the linear congruence. But before that, let's talk about introduction to congruences. Gauss and congruence. Carl Friedrich Gauss 1777 to 1855 has been called the Prince of Mathematicians for his many contributions to pure and applied mathematics. He was born to poor parents in Germany. His high intelligence was noticed early and nurtured by his mother and uncle, but his father never encouraged Gauss in his education. One of Gauss' most important contributions to the number theory involved the invention of the idea of congruence or agreement in numbers and the use of what he called modulus or small measure or sets of numbers. In effect, his theory of congruence allows people to break up the infinite series of whole numbers into smaller, more manageable chunks of numbers, perform computation upon them. This arrangement makes the everyday arithmetic involved in such things as telling time much easier to program into computers. Gauss said that if one number is subtracted from another, a minus b, and the remainder of the subtraction can be divided by another number, m, then a and b are congruent to each other by the number m. Gauss' formula is follows: A is congruent to B modulo M. As we mentioned in the introduction, the theory of congruences was developed by Gauss at the beginning of the 19th century. Let M be a positive integer, we say that A is congruent to B modulo M if M divides A minus B, where A and B are integers. If A is equal to B plus Km, where K is an element of C. If A is congruent to B modulo M, we write A is congruent to B mod M. Theorem, properties of congruences. Let A, B, C, and D denote integers. Let M be a positive integers, then number 1. If A is congruent to B mod M, then B is congruent to A mod M. Number 2. If A is congruent to B mod M and B is congruent to C mod M, then A is congruent to C mod M. Number 3. If A is congruent to B mod M, then A plus C is congruent to B plus C mod M. Number 4. If A is congruent to B mod M, then A minus C is congruent to B minus C mod M. Number 5. If A is congruent to B mod M, then AC is congruent to BC mod M. Number 6. If A is congruent to B mod M, then AC is congruent to BC mod MC, for C is greater than 0. Number 7. If A is congruent to B mod M and C is congruent to D mod M, then A plus C is congruent to B plus D mod M. Number 8. If A is congruent to B mod M and C is congruent to D mod M, then A minus C is congruent to B minus D mod M. Lastly, if A is congruent to B mod M and C is congruent to D mod M, then AC is congruent to BD mod M. So now let's focus about linear congruence. Generally, linear congruence is a problem of finding an integer x that satisfies the equation ax is congruent to b mod m. Thus, a linear congruence is a congruence in the form of AX is congruent to mod m, where x is an unknown integer. In a linear congruence where x0 is the solution, all the integer x1 or x1 is congruent to x0 mod m. Let's have an example for this linear congruence, but before that, we need to familiarize this method. Rules for finding x in the linear congruence. First, find GCD of AN equals D. Second, B divided by D if possible solution exists. Third, find D mod N. This number of solutions are possible. Fourth, divide both the sides by D. Fifth, multiply both the sides by multiplicative inverse of A inverse. For example, A into A inverse x equals B into A inverse mod n. Lastly, general solution of the equation n is xk equals x0 plus k times n divided by d, where k is equals 0, 1, 2, and so on, d minus 1. The general format is ax is congruent to b mod n. For example, 14x is congruent to 12 mod 18. Since our general form is ax is congruent to b mod n, now we need to get the value in the 14x is congruent to 12 mod 18. Our a is 14, b is 12, n is 18. As I said earlier, familiarize those rules in the method. First, we need to find the GCD, at kapag nakuha na ang value ng GCD natin, ito na rin ang magiging value ng D dito sa example. Kung paano nakuha ang GCD, I put the solving in the right side. Kahit di na natin isolve ng katulad niyan, malalaman agad natin na 2 ang value ng GCD kasi both even numbers sila. Sa step 2 naman, B divided by D is equal to, the value of B natin is 12 and the value of D natin is 2. So if we divide that numbers, we get 6. Since B divides D, there is a solution. Third is D mod n equals 2 mod 18 equals 2. Paano naging 2 yan? Because we got the smaller number so that we have 2 solution exist. Fourth step, divide both the sides by D. 14x is congruent to 12 mod 18 over 2. When we divide it, we get this 7x equals 6 mod 9. Our fifth step is to multiply by multiplicative inverse of A. 7x is congruent to 6 mod 9. 7 into 7 inverse x is congruent to 6 into 7 inverse mod 9. Cancel the 7 into 7 inverse, so we get 6 is congruent to 6 into 7 inverse mod 9. To find the inverse, we need to do extended Euclidean method, but it is easy if we interpret like this. 7 into C mod n equals 1. 7 into C mod 9 equals 1. The C is the 7 inverse. So, hanapin natin yung value ng C at i-multiply natin sa 7. Ang gawin natin dito ay mag-trial and error. So, ipagpalagay natin na ang C ay equals to 1. 7 mod 9 is not equal to 1. If C equals to 14 mod 9 is not equal to 1. If C equals 3, 21 mod 9 is not equal to 1. If C equals to 4, 28 mod 9 is equal to 1. Bakit siya equal sa 1? Kasi yung 28 divided by 9 is 3 and the remainder is 1. So, it is equal to 1. Next is, we need to do is papalitan natin ang 7 inverse into 4. So, x equals 6 into 4 mod 9. 6 times 4 is 24. So, x equals 24 mod 9. Our value of x0 is 6. Paano naging 6 yan? 24 divided by 9 is 2. The remainder is 6. So, our first solution is 6. Lastly, xk equals x0 plus k times n divided by d. Since meron na tayong x0, the second solution would be x sub 1 or x1. x1 equals 6 plus 1 times 18 over 2. Yung 6 is the value of x0 and yung 1 is k. Yung 18 over 2 ay nakuha doon sa previous nating equation, which is the 14x is congruent to 12 mod 18. X plus 1 times 9 equals x plus 9 is 15. Our value of x1 is 15. It is the second solution. For more examples and better understanding about this topic, you can visit the links that I listed here. Thank you for listening and watching this video.